Assalamu alaikum. Today I am going to discuss about distance and displacement. Distance and displacement. Distance, a total path covered by an object irrespectively to its direction is called distance. So distance is a scalar quantity. Distance is a scalar quantity. It is a scalar quantity because it has only magnitude, no direction. Unit of distance is meter. So remember, unit of distance is meter. On the other hand, total path covered by an object in a particular direction. Particular direction means in a specific direction. The total path covered by an object in a particular direction is called displacement. Displacement is a vector quantity because it has both magnitude and direction. The unit of displacement is same as the distance, meter. But remember, displacement is a vector quantity, so it has direction, particular direction. Say 5 meter is the distance, but 5 meter north is a displacement because north it has a particular direction. Now, uniform speed. A body has a uniform speed if it travels equal distance in equal interval of time. So the rate of change of distance is called speed. A vehicle moving at constant speed on the straight road. A cyclist is covering 5 km uniformly in every 1 hour. So unit of speed is meter per second. The SI unit of speed equal to meter per second. Why meter per second? Because we know there is a formula, speed equal to distance divided by time. Distance divided by time. Unit of distance is meter and unit of time is second, so meter per second. Remember, speed is a scalar quantity because it has the rate of change of distance. Distance is a scalar quantity, that's why speed is a scalar quantity. Now, average speed. If a body does not move with uniform speed, then average speed is obtained dividing the total distance traversed by time. Formula for average speed, total distance divided by total time. In physics, speed is usually measured meter per second. So average speed equal to, speed equal to total distance by total time. Total distance divided by total time taken. So remember, average speed equal to total distance by total time. Unit is meter per second, same. Now there is a formula triangle. Distance, speed and time. So distance equal to speed into time and time equal to distance divided by speed. So speed equal to distance moved. So distance divided by time taken. So distance divided by time taken. Next, speed, unit conversion. So remember 1 kilometer per hour, so 1000 meter per hour, but 1 hour equals to 3600 seconds. So therefore 1 kilometer per hour equal to 1000 meter divided by 3600 second. So 1 kilometer per hour equals to 0.28 meter per second. So 1 meter per second equal to 3.6 kilometer per hour. There is a mathematical problem. Calculate the average speed of the car that cover 500 meter in 20 seconds. 20 seconds. 500 meter in 20 seconds. So 500 meter is the total distance, and total time here 20 seconds. So 25 meter per second. 25 meter per second. Sound wave travel at about 340 meter per second through a air. How far will a sound wave travel in 1 minute? We know speed equal to distance divided by time taken. So distance equal to speed into time. So 340 is the speed, 340 meter per second, because 340 meter per second speed is given and time is 1 minute, but unit of speed is meter per second, so we have to convert this time 1 minute into second. We know 1 minute equal to 60 seconds, so 20,400 meter. So about 20.4 kilometer. Kilometer is the distance. Kilometer is distance. Next one. It is a distance time graph. Distance in the y-axis and time in the x-axis. Remember, when we plot a graph, then independent variable should place in the x-axis, and in y-axis we should place a dependent variable. Here distance is the dependent variable. So if distance time graph is a straight line, steeper straight line, then it shows the object moves with constant speed. So how we can calculate the speed here? So speed equal to remember, speed equal to gradient of the distance time graph. Gradient of the distance time graph. Remember, gradient of the distance time graph. Speed equal to gradient of the. How we can calculate gradient? Rise by run. Rise divided by run. So here rise 6,000 meter. On the other hand, run 240 second. So 0 cancel. So we can easily calculate speed of the moving object from this distance time graph. Look at the graph here, distance time graph. If the distance time graph has higher gradient, then it shows the object moving fast. And if the gradient of the gradient, so slope or gradient of the distance time graph increases with the speed. So if the graph shallower, that means less gradient, then it shows the object moves with slow or lower speed.